Hi, my name is Abhishek Yadav and I am from Azimgarh, Uttar Pradesh. Currently, I am pursuing BTech at NIT Manipur and my branch is Computer Science and Engineering, where I have maintained my aggregate CGPA of 8.51. So, my topic is metrics. So, in this particular slide, we will study what is metrics, what are the type of metrics, and what are the operation we can perform in a particular metrics. So let's start with what is matrix. Matrix is nothing, it is a collection of object, or we can also say that it is a collection of number. It whatever we put in a rectangular array, then we can say that it is a matrix. It can be in any fashion. It can be either 1 2 3 4 5 6, or it can be like 1 2 3 4 5 6. It can be in any fashions. So here these are we call rows and this is columns. So we can say that there are m rows and n columns. So we can also say that m cross n to find what the number of element in a particular matrix. Here it is also known as order of matrix. Now in short, we can write it in the form of aij, where we can put any value of I and j and we can get a particular element of a matrix. Now we'll move to next slide. Here we will study type of matrix. So there are different type of matrix. First one is row matrix. A matrix that has only one row and there can be multiple columns, then we can say that it is a row matrix. Here it is a 1 cross 4 matrix. So here the number of rows is only 1, then we can say that it is a row matrix. Also, if there is only one column, then we can say that it is a column matrix. There can be multiple rows, but there should only be one column. Now we'll move to next matrix, that is equal matrix. We can only say that a matrix is equal if the number of rows is same as the different number of rows in a matrix should be equal to the another matrix row, and number of columns in a matrix should be equal to number of column in another matrix. The second condition is that we can say that if the elements in a particular matrix are equal, like the numbers are same, then we can say that it is a equal matrix. Like we can say that 1 2 3 4 5 6, and here 1 2 3 4 5 6, then these two matrices are equal. Here there are there are total 2 rows, so we can say that 2 and total 3 columns, then we can say that it is a 2 cross 3. Similar here, it is also 2 cross 3 and the numbers are also equal. So we can say that it is a equal matrix. There are only 3 conditions we have to check and we can conclude that it is a equal matrix. Now we'll move to another matrix, that is square matrix. Any matrix with number of rows and number of columns are equal, then we can say that it is a square matrix. It can be either 2 cross 2 matrix, 3 cross 3 matrix, or 4 cross 4 matrix. Whenever the number of rows is equal to number of columns, then we can say that it is a square matrix. Now we'll move to diagonal matrix. What is diagonal matrix? A diagonal matrix is nothing but any value that are in diagonal form, then we can say that it is a diagonal matrix. Here it is 2 3 and 5, they are in diagonal form. If there is equal numbers in a diagonal, then we can say that it is a scalar matrix. So what is scalar matrix? Any value that in a diagonal are equal, then we can say that it is a scalar matrix. But if it is 1, then the name changes to identity matrix, also known as unit matrix. So now move to another matrix, that is upper triangular matrix. Upper triangular matrix, whenever a matrix is making a triangle in upper section, then we can say that it is a upper triangular matrix. And if we make a triangle in lower section, then we can say that it is a lower triangular matrix. Now that's all for type of matrix. Now we can move to next section, that is the operation that we can perform in an algebra, or we can say that in an algebra of a matrix. That is number one, addition. How we perform addition in a matrix. Here 1 2 3 4, here 1 2 3 4. If we want to perform the sum, then we can just add the first matrix with the first matrix. Then we can say that we will get a matrix of 2. Similarly, we'll add this 2, we'll get 4. Here we'll get 6, and here we'll get 8. So this is our new matrix. It is also in the form of 2 cross 2. So the order should be same. While adding a particular matrix, the order should be equal. So there are some property that we should do in a particular addition. There is commutative, like we can either add a plus b or we can add b plus a, we'll get the same value. Now the next property is associativity. If we add two matrix and rather after that we'll add the another matrix, we'll get same value as if we can add either 2 here or either 2 here, we will get the same matrix. Now existing of identities, like if we add a matrix with 0, then we'll get the same matrix. What is existence of inverse? If we add a matrix with the negative of another matrix, we'll get 0. Cancellation law. What is cancellation law? When we say that a plus b is equal to a plus c, then it means that b is equal to c. Then we can say that these two matrices are equal. Now see, as we have done in addition, subtraction is also same, and the properties are also same for subtraction also. Now we'll move to next topic, that is scalar multiplication. What is scalar multiplication? It is nothing but if we take a matrix like 1 2 3 and 4, here if we multiply anything like 2, then we have to multiply in each number. So we'll get 2 4 6 8. So if we multiply a scalar multiplication like scalar number with a matrix, we'll get a new matrix. The properties of a scalar matrix are like, if we are multiplying in, if we are adding a matrix, then we are multiplying, then we can open it like to get our value. Similarly, there are some scalar multiplication properties. Now what is matrix multiplication? For understanding matrix multiplication, the first rule is the row the column of first matrix should be equal to the row of that particular matrix. There should be two matrices. The column of a matrix should be equal to row of another matrix. Then we can perform matrix multiplication. And the new matrix will be in the form of M cross P. Let's start. Let we perform a matrix multiplication in this particular example. Here we have to multiply We have to multiply a row and a column together, like minus 1 into 2. We'll multiply these two first and we'll add up and perform multiplication on this minus 1 into 1. Similarly, we'll move to next row and but same column, 3 into 2 plus 0 into 0. Here now we'll move next. You can either perform vice versa also. So here we'll get minus 1 into 0 plus 0 into minus 1 and 3 into 0 plus 0 into minus 1. So we'll get a value. Here it is minus 2 plus, then it is minus 3. Here it is 3 plus into 2, it is 6. Here it is 0 and here it is 0. This is our new matrix. This is how we multiply our matrix. We'll go row wise and column wise. There are some properties of matrix multiplication. This is associativity, distributed over addition. Here, if we are performing multiplication on A and B and we are again multiplying C, then it is also equal. We can also multiply B and C lightly like alag. Now there are some more properties. This is important for JEE mains. That is A, if A square is equal to A, then we can say that it is idempotent matrix. And if we perform an equal to 0, if a raised to the power n equal to 0, then we can say that it is a nilpotent matrix. And here n is called order of nilpotency. But one condition you have to, it should be there in your mind, that a raised to the power n minus 1 should not be equal to 0. Here we have to perform a matrix multiplication. So we'll go 2 0 7 0 1 0 1 minus 2 1 minus x 14x 7x 0 1 0 x minus 4x minus 2x. We have to first, and it has said that it should be equal to identity matrix. So what is identity matrix? I have mentioned earlier that if the diagonal values are equal and it should be 1, then we can say that it is an identity matrix, and rest of the values are 0. So to perform this, we have to take a row and column. 2 into minus x plus 0 into 0 plus 7 into x. From here we can say that it should be equal to 1. So we can perform minus 2x plus 7x equal to 1, then it is 5x equal to 1, then x equal to 1 by 5. So our value is, you don't need to solve whole problem, just take a value and solve a particular problem. Now you will think, what is the use of this matrix? I know it is not used in school that much, but trust me, it is very useful in a college. As I am from computer science engineering branch, it is used a lot in college. So thank you.